Okay, so let's start our new semester, new semester break with a random variable. Okay, this is quite a confusing topic because first and foremost you need to differentiate there are two types of things. One is distribution. Another one is continuous. For today, I'll be concentrating more on distribution, and I'll finish this one first before we move on to continuous. You need to know which one is which. What is distribution? It's when things are specific, like 1, 2, 3. How many people are in the class? Like 40, 30. It's a whole number. Okay, but continuous is something like what's your height? More or less like continuous is something like give you a bell curve graph. Distribution is something like going to give you more like a histogram. Okay, so this is the most basic of all. We go through the distribution first. Once we finish, then only we go to continuous. You need to know the difference. This is like a height or weight. It's a number of stuff. Right, so let's begin. Okay, so for today we'll be focusing on distribution and just a very small aspect of distribution. Today for distribution we'll be only going through probability table, probability distribution table, cumulative distribution table, and another thing we'll go through probability distribution formula function, and cumulative distribution function. We'll only be doing these 4 things. For these topics, you need to know what you are doing because for each section, the works are different. Most of the time, people will get mistakes because they use distribution or continuous. They mix up the formulas, just like limits. Okay, so let's begin. Okay, the basic things I can say to you, let's say I bring our very advanced stuff, coins. Let's say this is head, this is tails, and I'm going to toss them up. Let's play a little game. Okay, outside of screen. Head or tail? Head or tail? Okay. Head, raise up your hand. Tail, don't raise your hand. Tail, raise your leg. Okay, head, raise your hand. Head, raise your hand. Oh, it's a tail. So the one who raise your leg win. Okay, right now, but if I throw 2 coins. Oops. I lost the coin. Class cancel. Okay, if only 1 coin, how much is the for head or tail? If only 1 coin, probability 50-50, half. Right now, if I give 2, what's the possible outcome you're gonna have? You're gonna have head or head tail head, the same thing, okay? Or tail. Okay. Now, what's the probability for you to get head? What about head tail? Head and tail, it doesn't matter, tail or head. What about tail and tail? Okay, by the way, the answer, this one you got head and tail. Yes, for you to get head, probability for you to get head is 1/2. So head, 1 over 4. Head, tail, still 1 over 4. 1 over 4, 1 over 2, 1 over 2, so 1 over 4. Tail head, 1 over 2, 1 over 2, 1 over 4. Or tail, 1 over 4. Okay, then I can ask this sort of question. What's the probability for you to get heads? I can say 0 head, 1 head, or 2 head. Agree? No head, 1 head, 2 heads. So for 0 head, what's the probability for me to get 0 heads? 1 over 4. What's the probability for me to get 1 head? 2 here. 1 over 2. Now what's the probability for me to get 2 heads? 1 over 4. So mostly for this topic is we are going to do this sort of table. Now let me ask you one thing. The most important thing for this topic is, what's the total probability? You add all of this, you get equals to 1. Alright? So the total for down here is still equals to 1. And this is what we call probability distribution table. Okay, I know the probability for each distribution, and it's a table. So that's a very good introduction for you. And sometimes, to make things a bit worse, I don't think you'll be asked to find, but they will give you something like this. I can write down this is as x, the heads as x. This x equals to x, the small x, and then this one is big X, and then this one is small x. It's big X, this is small x. I can also rewrite it as this. This is what we call probability distribution function. It's just a difference of table or function. Can you see that? Can you hear my voice at the back? Start of new semester, so normally my voice is a bit low. People at the back, if you can't hear my voice, just raise your hand, okay? Okay, this thing here, it might look different. Alright, at first glance, if you firstly see this, you might ask, what the heck is this? Basically, it's saying when x is 1, when x is 0, it's 1 over 4. When x is 2, it's 1 over 4. When x is 1, it's 1 over 2. What does it mean again, sir? Well, you can change this into a table. So from here, I can say that I can write down firstly x. I've got here 0, 1, and 2, right? So 0, 1, and 2, and then I write them out. When it's 0, the probability is 1 over 4. When it's 1, the probability is 1 over 2. When it's 2, the probability is 1 over 4. Which gives you the same as this one. Are you okay? So when you see this sort of function, don't get panic. Just be calm and write them down one by one. Okay, don't worry, I'll show you more examples soon. And yes, you can also ask, how does a graph looks like? So this is a table. This is the function. Now, what about the graph? You've seen it in Excel a lot of times. If I were to say, this is your x, this is your probability. How many x do we have? 0, 1, and 2. Okay? So 0, 1, and 2. Are you guys following me? Okay? So the probability for 0 is 1 over 4. Probability for 1, 1 over 2. Probability for 2, 1 over 4. The graph is going to look something like this. I'm going to make it big bold here. Okay. But normally if you ask me draw it, sir, I might just do something like this. Just to make things a bit pretty. It doesn't, let me remind you again, it doesn't go something like this. This is for continuous. If it's just single line, it's a distribution. Are you okay? Can we continue? Alright, now what about if I ask you a dice? Or a die as a singular. I don't ask you to die, I'm talking about the dice. Okay, for those who do not know that die is a singular, dice is a plural. Yeah, I know that. Oh, okay. It took me when I was 20 years old and I only know about this. Okay, if you got a single die, which is 6-sided die, don't die, okay? If a 6-sided die, so it's a, you can get what number on a die? 1, 2, 3, 4, 5, and 6. Now, what about the probability? 1 over 6, 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 1 over 6. Are you okay? So, okay, make a proper table. I think that's okay. Okay, not bad for a free hand. And the question can ask you something like this. Now, what the probability for you to get Px less than 3? Which one is less than 3? Until where? 1 and 2 only. What about 3? It's less than 3. Okay, so if less than 3, so it's the same as Px less or equals to 2. Are you following me? So for this one, we just do Px equals to 1 plus Px equals to 2, which is 1 over 6 plus 1 over 6, 2 over 6, 1 over 3. So if I throw a die, and for you to get less than 3, it just, the probability is 1 over 3. Instead of you calculating, okay, the main reason for this topic is instead of you calculating one by one, they set out a table for you to quickly find the answers. Right? Don't worry, today we'll go through easy examples because it's a new concept. And what about if I ask you extra questions? Oh, sometimes the question can ask you something like this. What about probability of this one? Can you see? 1 until 3. More than 1 less or equals to 3. So which one is this? More than 1? This X. Less or equals to 3? This X. So it's only 2 and 3. So what's the probability? Same. Well, it depends. You can be precise. Are you okay? But I don't mind if you go from here and then you jump here. But of course, if your answer is wrong, this is a good way to get your marks, working marks. Can I move on? Okay, let me ask you again one more time. What's the total of down here? Kx equals to 1, okay? You're going to need that information. Now, the exam normal questions will look something like this with a level 1 tutorial. Difficulties. Let's say you're given something like this, kx, where k, 5 minus x, 0, x equals to 1, 3. Alright, so this is the distribution function. This is the function, not table. As I mentioned before, don't panic. Let's try sort it out. Probability distribution function. Okay, how do we start? Firstly, write down your x. And what's your smallest number of x? 1. And then 2, 3, 4. Now for the probability, big X equals to small x. 1 is kx, right? Now replace your x as with the 1. So it becomes k. Okay, continue. What about for 2? K, 5 minus 2. 3k. Are you still alive? Now what about 3? 3k. 4. 5 minus 4? 1. K. Now what is k? What's the value of k? How are you going to find? What information that we know about this thing? If I plus everything, it's going to be equals to 1. So, k plus 3k plus 3k plus k equals to 1. How many k we have? We have 8k. Sorry, handwriting over there. So k is 1 over 8. Are you guys seeing it on the screen? Are you okay? Good. So once you get k or 1 over 8, the next question might come in exam is, okay, now write down the distribution table. Okay, this is normal exam questions. They might give you something like this, and the next question going to say, okay, now construct the probability distribution table. So basically, we just draw the whole thing. Besides writing down k, we write down k is 1 over 8. And going as gentle as I can. Are you guys okay? I hope you guys okay. Okay, so normally when you find the value of k in exams, you need to draw them back without the k. Are you guys okay? Okay. That's a joke actually. Okay, then of course sometimes they can ask you a very simple questions. What's the mode? What's the mode? Which one has the highest value over there? 3 over 8, 3 over 8, right? So the mode is 3 over 8. The mode is here. 2 and 3. Okay, Okay, let's say a few more things. There's testing you. What about for p x more than 2? If more than 2 is which one? 3 and 4. So the answer is 4/8 or 1/2 over here. Now about if I ask you, oh, this is something interesting. Px equals to 1 or x equals to 4. This is interesting. What do you think? 1 is this one here. 4 is over here. So how should we write down our final answer? Should you plus or what? Yep, you should plus. Or is combination of both things. So yeah, it's a 2/8, 1/4. You guys okay? Hopefully you're still not dying. Okay, so what we have done is this, that we have touched these two. So you know them well, okay? You know them well. Now we are going to this one here, cumulative distribution table. Okay, before I go further, what does the word cumulative means? You add up, you add up, you add up, add up, okay? From the beginning until the end. Like if I give you homework, 1 page. Bio give you another page. Physics give you another page. The total cumulative of homework, how many pages? 3 pages. Okay, so the things going to add up, add up, add up, so it becomes more and more and more. So in short, cumulative, you have seen this in your school days before. It's very, very, very similar to. Are you familiar with this word? Or maybe I'm using the Malay word. Or give or give, whatever you want to say. Remember with this kind of graph? So it's sort of that. It's sort of that. But you need to remember, this one is continuous. This one is continuous. So how does cumulative works for distribution? Which is discrete. I forgot to use the word. It's something like this. It will look something like that. Okay, never mind. We'll go further soon. Okay, let's say we continue with this now. This is why I need a computer, but the computer is not functioning today. Okay, let's say we continue with this one. Sorry if I reuse my table here. And then right now I want to find cumulative distribution table. Okay, this is probability distribution table. Now I'm going for the cumulative distribution table. So it's still the same. X 1, 2, 3, 4. And instead of over here normally we write down as P, X equals to X. Big X, small x. We use the word P there. For this one here, we use F. Or to be more exact, big F. Or maybe capital F. Alright, so what's the probability for you to get 1? 1/8. When 2 here, it means 1 and 2. What's the probability for you to get 1 and 2? Add up these two. 4/8. Okay, for the sake of to make our calculation over here easy, let's not simplify them yet. Let's write down 4 over 8 first. What's the probability for you to get 3? 1, 2, and 3. 7 over 8. What's the probability for you to get 1, 2, 3, and 4? 8 over 8 or 1. Okay, so it's an add up. I'm trying to go as slow as possible for you right now. Okay, so the graph, how does it look like? Before I go further, how does this graph look like? Let's say here's a 1, 2, 3, 4. So 1 over 8, 3 over 8. The graph going to look something like this. Are you okay? Okay, let me ask you one question. Where is 1 in here? Where is 1 in here? When you add all of them, you got 1. Alright? Now let's try and draw this graph. Let me ask you one more time. What does cumulative means? You add things up. Alright? So, for you to get 1 is 1 over 8. The graph is going to look something like, not yet. It's 1 until 2. It looks something like this. You touch 1. Right? Are you guys following me? You touch 1. Full hold, then it's a full dot there. And a whole dot here. You draw a line. Are you guys still alive? Okay. Just a full dot here and then draw a line. And you might ask, sir, why full dot, sir? Because it's 1. You reach 1. Why is it a whole dot here? Because you never reach 2. You never reach 2. Remember, this is a distribution, not like a weight. It's a number of things. Okay, what about 2? 4 over 8. So we draw full dot here and over here, whole dot, make a line. What about 3? 7 over 8. Yeah, same. Sorry, drawing is not based on scale. And what about the rest? More than 4. You draw 1 dot here. And just do it that way. What's the value here? 1. This is big F. This is X. So I want you to know the difference between probability distribution graph and then the cumulative graph. As I've mentioned before, you remember your OGIF in your school days? It looks something like this. That's your OGIF graph. Alright, of course I can ask you a question something like this. This is a trick one. Ready, class? Now what about the median? Median is 0.5, right? So where's the 0.5 here? It comes straight here. So the median is 2. Are you guys okay? Sorry, my screen monitor is not working, so I'm not sure whether you can see or not. Alright, good. Stay alive. Let's continue. Okay, let's say you're given this kind of graph this time. This one just small x. Okay, what sort of table is this? Is it a cumulative or non-cumulative? Cumulative, why is it a cumulative? It's a big F here. Or capital F, okay? Now, let me ask you, what about the probability for you to get Px less than 3? If less than 3 for distribution, does it mean equals to 3? We're just taking Px less equals to 2, okay? Of course, you can mention before that this is 1 plus 2. So should I do 0.2 plus 0.32? Is the answer is 0.34, 0.52? Why not? I mean, this is what we used to do. If I want less than 2 or equals to 2, so I add two things. Can someone tell me why this is the wrong answer? Because this is cumulative. Cumulative, what's the difference? What's the meaning of cumulatives? You add up. So in this case, 0.32, it already add up. Understand? It already add up. So that this is not the answers. The answers is 0.32. Because it already add up. I need you to understand this concept well. Do you want me to explain again? Are you guys okay? It already add up. Understand that one? Okay, now what about if I ask you find the median? This one is a bit tricky. I'll be honest, sometimes even I still sometimes get confused. Median is what? 0.5, right? Is 0.5 contained here? Is 0.5 contained here? Not yet. This is only 0.32. Is 0.5 contained inside here? Yes, 0.5 is inside here. So the answer is 3. Okay, the 0.5 is in here. Got it? As simple as that. But I'll be honest with you, even I sometimes still got confused of that. This is one thing before exams that I'll have a look again. What's the median for me to find in probability distribution function or cumulative distribution function? Table in this case. Okay, so just now what we did was from this one, from the table, we find from probability distribution table we find the cumulative. Okay. Now we want to do the reverse process. We want to find from the cumulative to find the table instead, to find the probability distribution table instead. Okay. So for this one, how do you reverse the process? It's easier to add up rather than minus. Okay, so let's draw here to save our time. Now, what probability for you to get 1? 0.2. Probability for you to get 2? 0.32 minus 0.2. How we got here? Normally we add up, right? So we minus them back. 0.12. Probability for you to get 3? 0.67 minus 0.32. Just minus everything with before. 0.35. What about 0.9? What about 4? 0.9 minus 0.67. 0.23. What about for you to get 5? Minus these two. 0.1. You just minus things back. You need to try it by yourself, then you get it. You see me doing things, you won't get it so much. Just minus the things before. Okay, so let's move on to another example. Let's say you're given something like this. Oh yeah, sometimes it can be a bit tough. You will start with this. This is the function. Is it a cumulative or non-cumulative function? Normally, I'll just call them cumulative or non-cumulative. Rather than use the word probability is a bit weird for me. Right, so firstly, you got this one. How do you draw the table? You want to try it out so we compare our answers? I'll give you 2 minutes. Okay, I want you to give me 2 tables. One is the probability distribution table. Another one is cumulative distribution table. One is the P, one is the big F. How do you start if you do this question? Write down the X firstly. So what X do you have? Negative 1, 0, 1, 2. And then you do the P. Once you calculate the P, find me the cumulative. Okay? Hopefully it's not too difficult for you. Right, do we got the same answer? You got the same? Now, let me ask you an extra question which is not in the lecture note. Draw me the graph for this one and for this one. Draw me the graph. You might argue with me, sir, negative 1 is over here, sir. You can do at the back, but that's a weird graph. But as well as the graph, you can manipulate things where you want to put your axis. I prefer this way. Someone like to put negative 1 over here, someone over there. This one is easier to see with the eyes. You got the same? It's a probability distribution graph. Now what about for the cumulative? Oh, you can see them. I'm going to freeze it for a while. Good luck trying. The camera is freeze. Are you done? Let's compare our answers. Drum roll, please. Sorry. I forgot the button. Okay. Forgot one thing. This one is X. This one is big F. This one is X. This one is P. Okay, so this one is called what? What is this? Probability, distribution, function. What about this? This one here? Probability, distribution, table. What about this? Cumulative, distribution, table. So we have learned 1, 2, and 3. I haven't teach you this. The last one, the big boss. Oh, before I go further, let me ask you, where's the median? Extra question, where's the median? The median is 1. Why? Is 0.5 here? 0.5 here? 0.5 here? Yes, it's 1. If you got that, I'm very proud of you. Okay, now the last one. Cumulative, distribution, function, and there are many ways on how to get this one. Each lecturer will have their own style, but ultimately it will go to the same things. Class, please listen to this one. This is like the most marks at the end. So you got yourself -1, 0, 1, and 2. The function start from this one. We draw this one. 1 over 10, 3 over 10, 6 over 10, and 1. Okay? You copy this one first. Where do you get 1 over 10? Okay, I think you need to write down this one first. Okay, before you got here, before you can go until there, it starts from where? It starts from 0. There is 1 here, 0. When do you get 0? What's the value of x when you got 0? Less than -1. Okay? You take your lowest value, x less than your lowest value. Are you okay? There are many ways to get. This is just one of them, I'm telling you. When do you get 1? The highest value more than the highest value. More or equals to? So x more or equals to 2. And then from here, it's just in the middle then. Where do you get 1? When do you get 1 over 10? From -1 until 0. Which one has a full dot? -1. So equal over here. It's just a matter of translating back. When do you get 3 over 10? Between 0 until 1. Why this is 1? If this one is a full dot, that means equal over here. Last one. Between 1 and 2. Very good. Full dot where? 1. You got this far and finishing things up. This might not be the most efficient, but other lecturers, they just have a slightly different variation, going to give you the same things. Alright? Okay, I think that's all for today. So you have learned all these 4 things. Just a little bit recap. This one is the table. Something like this. The function. Something like this. don't be panic. Cumulative distribution table is when you add all things up. Cumulative distribution function is something like this. Okay, you might want to draw the graph before you draw this, or any other ways, as long as you can get the answers. Remember, there are two types of graph. Probability distribution is something like this. Where is the one in this case? Where is the one? When I add all things up. Where is the one in this case? Up here, sir. Alright. If I ask you px, let's say for this case, if I ask you for px less than, let's say 1, which one should I take? Should I take 1? Why not? There's no equal here, so it's supposed to be less or equals to 0. So that means px equals to 0 plus px equals to 1. Sorry. Negative 1 and 0 over here. Are you okay? Where's my answers? Where's my answer for this? This plus this or this plus this? This one, right? This one plus this. Give me the answer. Or I can simply take this one. Either this one, I add up, or simply this one. But this one I can just take like that, sir, because this one is an add up from this one. Okay, which one you're going to do in exam, which strategy, it depends which one you are not confused. Yeah, this one is faster, but if you got confused, then take the one that you are efficient with. Alright, that's all for today. Please get to know all these things. Don't get confused, and you'll be fine. Alright, that's all. Thank you for listening. Please comment, share, like, subscribe. Hi, new semester. New semester after the sem break. Everybody's rindu holiday, missing the holiday.